Now we are going to discuss about the curl of a vector field. Now in the previous video we talked about the divergence of a vector field, and we defined the divergence of a vector field equals to grad dot f. So gradient is the vector operator, and this gradient operator acts on f, and we use the dot product. Now when we calculate the curl of a vector field, instead of taking the dot product, we take the cross product. Okay, let's define the curl of a vector field. So if we have a vector field f with three components, f1, f2 and f3, the curl of vector field f is the vector. Now we are going to get a vector. We denote the curl of a vector field using grad cross f. This is the cross product. Grad cross f equals to determinant. Now we are going to take the cross product of two vectors. Okay, so in the first row we have ij and k. Now in the second row we have the components of the gradient operator. And finally we have the components of the vector field f1, f2 and f3. This equals to partial over partial y of f3 minus partial over partial c of f2 times vector I, then minus j times partial over partial x of f3 minus partial over partial c of f1 plus partial over partial x of f2 minus partial over partial y of f1 times vector k. And this is the way we define the curl of a vector field. Now you must remember one important thing. This is not a product. This is the derivative of f3 with respect to the y variable. Similarly, here we should take the derivative of f2 with respect to the c variable, and so on. Let's consider an example. Let's say we are given a vector field f that equals to x comma xy comma 1. Let's find curl of f. Grad cross f. Okay. Now this equals to the determinant. In the first row we should have the standard vectors ij and k. Next we have the components of the gradient operator. And finally, we have the components of the vector field F, x, xy, and 1. So now we get partial over partial y of 1 minus partial over partial c of xy times vector I. The second one is a negative quantity. We have partial over partial x of 1 minus partial over partial c of x plus the third component, which is given by partial over partial x of xy minus partial over partial y of x. If you simplify this, derivative of 1 with respect to the y variable is 0. 0 minus derivative of xy, the product xy with respect to the c variable is also 0. So the first component becomes 0 minus again derivative of 1 with respect to the x is 0 minus derivative of x with respect to the c variable is also 0 plus now partial over partial x of xy, now you will get y minus 0 times vector k. Now if you simplify this, you should get 0I plus 0j plus y times vector k. Now as you can see, when we take the curl of a vector field, the result should be a vector quantity, because curl comes from the cross product of two vectors. Let's consider one more example. Okay. Example number 2. Find the curl of vector field F that equals to xy minus sin c, comma 1. Okay, so curl of F equals to the determinant of first row we have ijk, and in the second row we have partial over partial x, partial over partial y, and partial over partial c. Now in the third row we should have the components of the vector field. They are xy minus sin c and 1. Okay. If you take this cross product, you should get partial over partial y of 1 minus partial over partial c of minus sin c times vector I minus partial over partial x of 1 minus partial over partial c of xy plus partial over partial x of minus sin c minus partial over partial y of xy. Okay. Now we have derivative of 1 with respect to the y variable is 0. Minus times this minus becomes plus. Derivative of sin c with respect to the c variable is cosine c minus, first one is 0, minus derivative of xy with respect to the c variable is 0 plus derivative of minus sin c with respect to the x variable is 0 minus derivative of xy with respect to the y variable is x times k. So now we have cosine c times vector I plus 0, 0j minus x times vector k. If you want, you can write the same answer using dot parentheses. You should get this. And this is the way we calculate the curl of a vector field. And again, the divergence of a vector field is a scalar. However, the curl of a vector field is a vector quantity.